Hey, welcome to our second junior video on probability. We're going to chat about sample space. Now, probability is a way to measure the likeliness of an event occurring. It's measured on a scale from 0 to 1. And probability is written either as a fraction, a decimal, or a percentage. Right, we've spoken some key words in the last video. An outcome is a possible result of an experiment. Only one possible outcome will occur each time the experiment is conducted. An example, flipping one coin, there are two possible outcomes, a head or a tail, and only one of these outcomes is possible when we conduct the experiment. Right, so the list of all possible outcomes in an experiment is called a sample space. All possible outcomes, we call it a sample space. So let's show you what we mean. Here's example one, flipping one coin. When we flip one coin, there are only two possible outcomes. It's either going to be a head or it's going to be a tail. So the sample space is only two outcomes, H or T, we often abbreviate it to, and we like to stick these inside these wiggly brackets. Right, what about example two? When we flip two coins, what's the sample space going to be here? Well, here's all the possibilities that could happen. We could get two heads, and we often abbreviate it HH. We could get a head and a tail. We often abbreviate it HT. We could get a tail and a head. That's different to the outcome we just spoke about, because a head tail is a head on one coin and a tail on the other, and a tail head is a tail on the first coin and a head on the second. So it's a different outcome, and we could get tail tail. So four possible outcomes, so the sample space has to have all four outcomes inside these wiggly brackets. Right, what about rolling a die? What's the sample space for rolling a die? Now, when we talk about a die, we're talking about a standard die that's got 6 sides, numbered from 1 to 6, and each side is equal in terms of the die symmetrical, so there's no bias involved. So when we roll a die, there is not four, how silly. There are 6 possible outcomes for rolling a die. So the sample space is any number from 1 to 6. From 1, 2, 3, 4, 5, 6, the outcomes could be 1, 2, 3, 4, 5, or 6. What about rolling 2 dice? Now we're going to talk more about rolling 1 die and rolling 2 dice in another video later on. But as a very quick overview right now, when we roll 2 dice, there are 36 possible outcomes. 36, I said that. So we could get a 1 on the first die and a 1 on the second die. We could get a 1 on the first die and a 2 on the second die. A 1 on the first die and a 3 on the second die. We could get a 5 on the first die and a 1 on the second die. We could get a 6 on the first die and a 3 on the second die. There's 36 different combinations that could occur, and we'd have to write them all down as our sample space. Right, example 5. What about selecting a card from a pack of cards? Now, again, when we talk about a pack of cards, we talk about a standard pack of cards that's got 52 cards in it. I know a lot of packs these days have 2 jokers, but we often refer to a standard pack of cards just being the 52. So here are all the sample space of selecting a card from a pack of cards. Well, we just need to write down every single card on the deck. Ace of clubs, ace of diamonds, ace of hearts, ace of spades, 2 of clubs, 2 of diamonds, and so on. All the cards, all 52, would be my sample space because those are all the possible outcomes I could select. Right, when 2 experiments are combined to form one experiment, the sample space becomes a joint set. So what that means is if I was to roll a die and flip a coin, my sample space would become this. I could get a 1 on the die and a head on the coin. I could get a 2 on the die and a head on the coin, 3 on the die, head on the coin, 4 on the die, head on the coin, 5 on the dice, head on the coin, 6 on the die, head on the coin. Or I could get a 1 on the die, tail on the coin, 2 on the die, tail on the coin, and so on. So there are, I think, 12, I've had to count up, 12 outcomes in this sample space. All right, that's our second video done. Thanks for watching.